types of sets. In this module, you will learn about the different types of sets. Consider the collection of geometrical figures consisting of a triangle, a square, a rectangle, and a pentagon. In this collection, consider the set A of geometrical figure with 6 sides. Is there any such figure? Obviously no, there is no such figure. Hence, this set of figures containing 6 sides is an empty set. Thus, you can conclude that a set containing no element is called an empty set. An empty set is denoted either by the Greek alphabet phi or a pair of curly brackets with no element inside it. Can you count the number of stars present in our solar system? 1. Our solar system has a single star, that is the Sun. Hence, the set of stars present in our solar system contain only a single element, that is the Sun. Such a set containing exactly one element is called a singleton set. Can you count the number of books kept in a library? They are large in number. Still, you can count them, as there are a fixed number of books in a library. Hence, the set of books in library is a finite set. Thus, a set consisting of no element or definite number of elements is called a finite set. How about counting the stars in the sky? Quite impossible. Since the number of stars in the sky is not finite, you cannot count them. Hence, the set of stars in the sky is an infinite set. Thus, a set containing infinite number of elements is called an infinite set. Suppose you have 2 sets, A and B of eyeballs, each of the same color and size. When you mix the 2 sets, you cannot tell which ball belongs to which set, because both the sets contain exactly same balls. Hence, A and B are equal sets. Thus, the sets having exactly the same elements are called equal sets. Can you differentiate between equal sets and equivalent sets? Consider a set A of 10 pens and set B of 10 pencils. Both the sets A and B are different, but have same number of elements, and hence A and B are equivalent sets. Thus, 2 finite sets A and B are equivalent if they have the same number of elements. Consider the set X as the set of all the members of our solar system, and Y as the set of planets revolving around the Sun. You know that planets are a part of our solar system. So, the set of planets is the subset of our solar system. Thus, if every member of set Y is also a member of set X, then set Y is called a subset of set X, and set X is called the superset of set Y. In fact, the set of planets is strictly contained in the solar system, as it excludes other members like the Sun, natural satellites, and meteoroids, which are also parts of the solar system. Hence, the set of planets is not equal to the solar system. Thus, the set of planets is a proper subset of the solar system, because a subset is termed a proper subset only if it leaves out at least one element of the set. An empty set is a proper subset of all sets. Interestingly, a given set is a subset of itself. For example, all the members of the solar system belong to the solar system. The subset consisting of all the members of the given set is called an improper subset. Ever heard of a set of sets? Such a set of sets is called a power set. To be exact, power set of a set is the set of all its subsets. Let S be the set containing the elements 1, 2, and 3. Now, the subsets formed from this set are 5. 1, singleton 2, singleton 3, 1, 2, 2, 3, 3, 1, and 1, 2, 3. Hence, the set formed by all these subsets is the power set of set S and is denoted by P of S. A set is the subset of its power set. Let us line up the subsets that form a part of the power set. If S be the set consisting of elements 1, 2, and 3, then the empty set phi and the set S itself will always be the members of its power set. Hence, you can conclude that power set can never be empty. For the set S, you have 8 subsets, elements in the power set. Any guesses about how it becomes 8? Simple. 8 is obtained as to the power 3. So, for any set A containing m elements, its power set contains 2 to the power of m elements. That is, the order of a power set is 2 to the power n, where m stands for the number of elements in the set. A set which contains all sets under consideration is called a universal set. It is denoted by the letter U. Suppose you have a set X containing all the maths books in a library, and set Y as the set of all English books. Here, you are considering the different sets of books in a library. Hence, the set of all the books in the library is the universal set. In this module, you have learnt that a set containing no element is called an empty set. It is denoted either by phi or by a pair of curly brackets with no elements in it. A set containing one element is called a singleton set. A set containing a definite number of elements or no element at all is called a finite set. A set containing infinite number of elements is called an infinite set. Two sets A and B are said to be equal if all the elements of set A are in set B and vice versa. Two finite sets A and B are said to be equivalent if they have the same number of elements. Set A is said to be a subset of set B if all the elements of set A are in set B and it is denoted as set A is a subset of set B. Set A is said to be a proper subset of set B if all the elements of set A are in set B, but there is at least one element of set B which is not in set A. The set of all subsets of a given set is called its power set. A set which contains all sets under consideration is called a universal set.